Hey everyone, and welcome to this explainer. Today we're focusing on an absolutely fantastic part of Grade 7 Robotics, Unit 03. We're going to be unpacking the core concepts of program flow. So have you ever actually stopped to wonder what goes on inside a robot's brain when you press a button on a remote control? I mean, it kind of seems like magic, right? Well, spoiler alert, there are no tiny wizards in there. It's actually this beautifully structured sequence of logic. And throughout our time today, we're going to be answering a really crucial, essential question. How does program control flow make a robot's behavior more flexible? Because by the end of this, you won't just know how to drive a robot, you're actually going to know how to design the code that makes driving it possible in the first place.
Okay, let's dive right into our roadmap for today. First, we've got the remote control myth. Second, the continuous listening loop. Third, conditionals make the choice. Fourth, example forward or stop. And fifth, your challenge adding turns.
Section 1. The Remote Control Myth.
You know when you pick up a remote control, whether that's for your TV, your Xbox, or your classroom robot, it just feels incredibly intuitive. You push the joystick forward, and the robot moves forward. And because that physical action feels so direct, a lot of new programmers just assume the code works exactly the same way. So the myth is that when you press a button, the remote simply sends this direct, linear, one-time command straight to the motors. It honestly feels like you're physically pushing the wheels with your thumb, just connected by invisible Bluetooth wires. It's a totally logical assumption to make. But here's where we've got to bust that myth. If the code was literally just a linear list of direct, one-time commands, we would have a massive problem on our hands. Just imagine, you write a one-time command, drive forward. You press the button, the robot gets the command, and it starts driving. Awesome, right? Well, what happens when you let go of the button? If there's no continuous system in place checking to see if your finger is actually still on that button, the robot is just going to keep executing that one-time command forever. It drives away and bam, crashes right into the baseboards of your classroom. Just complete chaos. So the reality of program flow is totally different. A remote control program actually runs inside a continuous loop that is constantly checking for new inputs. It's not a one-and-done command. It's an ongoing, rapid-fire conversation between your controller and the robot's computer.
Moving right along, Section 2, the continuous listening loop.
To really wrap our heads around this continuous loop, I want you to think of a short-order cook working in a crazy busy diner. This chef doesn't just cook a single pancake, turn off the stove, and call it a day, right? No way. The chef is in a continuous loop. First, they ask the waiter for a new ticket, so that's asking for input. Next, they read the ticket to figure out what to cook, that's making a decision. And finally, they fry up the bacon or flip the eggs, that's executing the action. And the second that plate goes out the window, they repeat the whole process and ask for the very next ticket. Well, guess what? Your robot is doing the exact same thing hundreds of times a second. Ask for input from the remote, make a decision, execute the action, repeat. It literally never stops listening. This continuous loop is the absolute heartbeat of your remote control program.
Section 3, Conditionals. Make the choice.
All right, so this is where we introduce one of the absolute most powerful tools in your entire coding toolbox, the conditional. A conditional is an if-then statement, used in coding to create decision-making pathways based on specific inputs. Going back to our busy chef for a second, the conditional is essentially their recipe book. If the ticket says pancakes, then mix the batter. If the ticket says eggs, then crack a shell. The chef uses that input to choose a highly specific pathway. And your robot uses conditionals to do the exact same thing with the signals it's getting from the remote control.
Just look at how beautifully a conditional translates a physical, real-world action into a logical robotic response. If the forward button is pressed, then drive the motors forward. It's just incredibly elegant. We've taken the physical push of a plastic button, turned it into an electronic signal, caught that signal inside our continuous listening loop, and then used a conditional branch to tell the motors exactly what to do. The robot isn't just blindly following a list anymore. It's making a logical choice based entirely on the conditions that you, the programmer, have defined.
Let's look at this in action. Section 4. Example, forward or stop.
Let's actually build this out together step by step. This sequence right here creates a perfectly safe, fully functional remote control program. Step 1. The loop opens up and checks the controller for input. Step 2. We hit our very first conditional. If the forward button is currently pressed, the code branches off and runs the forward movement function. But what if it's not pressed? Well, that brings us to step 3, our second conditional. If the stop button is pressed, or honestly, more accurately in a lot of programs, if no buttons are being pressed at all, then run the stop function. Step 4, the cycle completes, and the loop repeats, jumping right back up to step 1. By sequencing our code this way, we can easily predict exactly how the robot will behave.
If we ever need to debug our robot, like say it's not stopping when we let go of the button, we know exactly where to look. We just check the conditional in step 3.
And you know, this perfectly illustrates the answer to our big essential question. How does program control flow make robot behavior more flexible? By structuring our program with loops and conditionals, rather than just a linear list of commands, we get 3 massive benefits. First, it creates super flexible behavior. The robot can react to totally different situations on the fly. Second, it prevents out-of-control robots. Because that stop command is built right into the continuous loop, the robot won't just drive away forever if you happen to drop the controller. And third, it continuously updates based on the user. The robot isn't locked into some pre-planned, rigid route. It's a highly responsive machine, entirely under your immediate control.
And finally, Section 5. Your challenge, adding turns.
So here's the deal. You know how to make it go forward, and you know exactly how to make it stop. But let's be real. Robots need to navigate around obstacles. They can't just drive in a straight line. So here's your transfer challenge as you head into your application task today. Think back to the code structure we just built. Where and how would you add a brand new conditional branch for a turn signal inside that exact same remote control loop? What would the if-then statement actually look like? And how would it sequence with the forward and stop functions we already made? I want you to really think about the logic, sketch out your flow, and get ready to program. Because remember, if you can master the loop and the conditional, you aren't just driving a machine anymore, you are quite literally giving it a brain. So how are you going to take control? Thanks so much for joining me on this explainer, and happy coding!